Hi, today I will show you how to fit a structure of a radio source with a set of Gaussians using difmap. I will be using a custom-made difmap settings file with some useful definitions. It is located at my home directory and is called .difmap. I have an environment variable set to tell difmap where to find this file, so the variable is called difmap_login equal to the path to my settings file. I have this data file that was observed with VLA at A configuration at C band, specifically C1 band. So let's go to difmap. I use the command observe and the name of the data file to read the file in. Now I will use the alias for a set of commands, which is go A configuration C1 band, go AC1. I have set the map size and pixel size and weighting, so all the good things. But before constructing a map, I want to get rid of any residual RFI. For this, I will use the command MEDT, which is the shorthand for Mojave style editing. It asks me about display. I reply /xw xwindow. So now what we have here is the amplitude of the visibility function, the correlated visibility, versus the baseline versus the UV radius, plotted in stocks V. The thing is that we are observing a faint radio source. Our source is faint and it is unpolarized. So its structure is hidden somewhere here deep in the noise. And these few points that show up as outliers on this plot are probably results of uncleaned RFI. So we want to remove them. To do this, I press C and draw a rectangle with the mouse. Click again, remove the points, right click, go to the next plot. This is the same thing, but now see the amplitude in stocks Q versus the baseline. So again, I will use C, click, draw a rectangle, click again, right mouse click to close this. Stocks U, same thing, I want to remove these outlier points. Right click. Okay, this is stocks I don't want to change it. This is another plot, I don't want to change it right now, so right click again, right click again. We are done with editing, let's make a map. Map plot. This is our radio source in the center. I want to zoom in. For this I press Z on the keyboard, click and drag, click again. Now I press K on the keyboard because I want to keep this zoom settings. So we see that the radio source consists of two blobs and we want to fit each of these blobs with a circular Gaussian. So let's do this. First I press N, point a mouse on the brightest pixel of one component of the source and left click. Then I drag the mouse to set approximate size of the component. Then I left click again. Then I press N again. At this point I have a new circular Gaussian component. Then I repeat this for the second source. N, click, drag, click, N. Okay, this is the starting point of our model. So now we exit mapplot by clicking the right mouse button. And we say model fit 50. 50 is the number of iterations. Takes some time to fit. I want to inspect the model. For this I say mapplot again. And this is the residual map, the data minus the model. So to see the model components I press M on the keyboard. And I don't like what I see, because you see one component is fitting most of the source and the other one is reduced to a small point-like source. So what I want to do is I want to edit this model. I exit mapplot with the right mouse click and I use the command edit add model. That's the command. So this command opens a text editor and shows me the difmap model file. Each line in this file describes a model component. First column is the model component flux. second and third are its position with respect to the face center in polar coordinates, and the fourth column is the size of the component. So what I want to do, I want to set the size of both components to 1 milliarcsecond, something small and definitely unresolved. And I want to remove this V letter, which tells difmap that it can vary this parameter. So I want to fix the size of both components to a very small value and allow difmap to only vary the component fluxes and positions. Save the text file and say model fit again. Let's look at the result with matplot. Again, this is the residual image. I use M to display the model components. So these are the two unresolved components of our model. And we see that there is some structure remaining here, so it's not a really good model fit, but it should be good enough for our purposes of measuring the distance between the two components and their fluxes, and seeing how this distance changes with time if we repeat this fitting procedure for multiple epochs spread in time. So I want to keep this model. For this I exit matplot and I use the command wmod, write the model, wmodel, and I tell it where to write the model, the file name, and we can see it here. This is the same text file we were editing earlier, so we can load it back in difmap if we need to. But there is another piece of information I want to say. This is what difmap is writing at the terminal. So for this I just use cat command and we'll name the file log, the same base name and then extension log. I just copy whatever difmap is writing here in the terminal. Ctrl D to finish the writing. So that's our file. Yeah, so here we have basically the same information about the two model components, but presented a bit differently and with fitting errors that we are interested in. The first column is the flux, second and third column are the position of the component, but now not in polar coordinates, but in equatorial coordinates. The equatorial coordinates computed by applying the presumably well-known coordinates of the face center. Size of the components, well, we fixed it, so there are no errors here, and so on. So this is basically what we want. We want these two files, the log file with model component parameters that difmap wrote into the terminal, and the mod file, which is the same thing but without fitting errors, but that can be loaded back into difmap if we needed to. So now we can repeat this fitting procedure for other epochs and see if fluxes and positions of the components change. So that's pretty much it. Thank you.